Okay, today we're going to start talking about section 2.2, direct variation. Direct variation, the topics that we're going to work on is recognizing what direct variation is, interpreting direct variation, and solving direct variation word problems or problems. Okay, direct variation is something that you guys all are familiar with, believe it or not. And there's also a tie-in to what we did in Algebra 1. So that may help us a little bit, but it does take us a little while to figure out what it is. Okay, direct variation is simply, it's an equation of a line that says y equals kx. And k in this case is going to be k is going to be the slope in this. And notice what the y-intercept is. The y-intercept is 0. Now, the k is a constant of variation. All right, and all the time, every single time, we're going to be looking for the constant of variation. Now, there's something called inverse variation and joint variation. We don't focus just on direct variation here for today. So when I have something like this and I want to be able to recognize, is this direct variation? The easiest way from a table of values is to simply go through and I want to see k is equal to y divided by x. So in the equation, y is equal to kx. If I want to find out if something is direct variation, I'm going to solve this equation for k, and end up with y is equal to kx. So in this case, if I take the y value and divide it by that, that's negative 7. Take negative 14 divided by 2, that's negative 7. Negative 7 divided by 1, negative 7. This is direct variation. The constant variation is negative 7. Now, this next one, that's a pretty blue, yellow. You want to see all the colors? Okay. So this next one, I don't again do k is equal to y over x. So in this case, this first one is 5 divided by 2. That's not very pretty, but you know what? We can deal with that. The next one is 7 divided by 3. Well, 7 thirds and 5 halves are definitely not equal. This is not direct variation. It's really that simple. All that you want to do is you want to take the k values, you want to find out what the k value is by dividing the y divided by the x, especially when you have a table. Now, if you're given coordinates, well, you can make that into a table the same thing. That's just an xy. It's an xy table just in a different format. So that's not a big deal for us to be able to do it. Now, let's look at these. And I have 4 different ones here. And the question is, which one of these graphs do you think are direct? All right, now you have to know, you can look at the equations, you can look at the graphs. To tell you the truth, the only one that's not is the second one there. And the reason that one is notice that all 3 of these all go through the origin. Well, in y equals kx, there is no y-intercept. The y-intercept is 0, so it'll always go through the origin. Now, the direct. What do you think the constant constant of variation is here? Well, k in this case is 3. K in this case is 1/2. This one, k is negative 1/6. Notice the easiest way for me to tell from an equation if it's direct variation or if it is not, I simply look, is there a y-intercept? If I'm looking at a graph, I'm simply looking for, does it go through the origin or does it not? If it does not, it is not direct variation. Now, I have another one here for you. Now, I put this into different format. You notice on the last slide, every equation was in slope-intercept form. Okay. Now, what happens if your line is not in slope-intercept form? Okay. What if it's in standard form? Okay. What if it's in point-slope form? Okay. So I'm going to look at the graphs on this case to see which one of these, hey, the only one that goes to the origin is the red one. So this one is, the others are not. Now, it sure was easy to look at this and decide this based on the graph. But let's say that I didn't do this based on the graph. Okay, let's start with this first one. So I have 3x plus 4y is equal to 24. I'd subtract the 3x to get it into slope-intercept form. And right now, I've already decided this 24 is not going to go away, and so therefore it's going to have a y-intercept. If I divide everything by 4, y is equal to negative 3/4 x plus 6. Don't want that. Okay, now the blue one. Now the blue one is in point slope form. So to do this in point slope form, all I'm going to do is I'm going to try to convert this back from point slope form into slope intercept form. And I really like point slope form. I think it really works well when you have a point and a slope. Now, first thing I do is I get rid of those parentheses. And then I add this 3 to this side. Well, that's not 0, is it? I don't know what it is, but it's not 0. Well, if I really wanted to figure out what it was, that's 15/3, so that's plus 8/3. But it's not 0, so that one doesn't work. And then the green one here. The green one, to do that one, all right, well, I can just get rid of the parentheses by rewriting it. And now I got to move this 4 over here, so there it goes. Now it has a slope. Now it has a y-intercept. It's not y is equal to k times x. Now the red one, the one that was, let's figure out what is k for that red one. So if I start off, it's 2x minus 7y equals 0. Honestly, in this case, I'm going to move this to the other side. So 2x is equal to 7y. Divide both sides by 7. So k is 2/7. Works out pretty quick and easy, okay? So almost every problem that I have, I'm going to try to convert it into slope-intercept form. It's easy for me to decide. The slope in this case is k. The y-intercept must be 0. That's the key to this. So if I look at the next set, okay, all right, I already discussed that quite a bit. So recognizing this. Now, if I look at this particular one, hey, B is an easy one. That's the one I'm going to start with because this is y is equal to 1/9 x. You can write it that way. Well, k is 1/9. That one's a piece of cake. Now this one, I got to move. I got to get this over to the other side. Then I got to divide everything by 3. Well, k is negative 5/3 then. And now, what happens if we get these into some sort of word problem? Something that goes along to life here. So the amount of money you make varies directly with the amount of hours you work. Well, duh, it still does. So in writing this out, the amount of money I make varies directly to the hours I work. There's the equation. I want to find out what k is. In this case, what I'm finding out is how much do I make per hour? So this would be 187.50 is equal to k times 15. I'm going to divide both sides by 15, and I get k is equal to, let's see here, that's 1, and that would make this a 3, and that looks like that's about 2 with 0.75 left. I didn't do the math all the way through here, but I think that's $12.50. That's the k value. Now, how much money will you make when h is 25 hours? So y is equal to $12.50 times 25 hours. All right, so y is equal to, and honestly, I don't have this in my head. I'm going to cheat and grab a calculator and come up with what this particular value is. Slowly but surely, I'm not very good at this. 87.5 divided by 15, 12.5, so I got that right, times 25. This is $312.50. Okay? Now, this is how much money you make. You think about it, any time that you work, my first job I got paid $2.25 per hour. So I know what k was. K was how much I got made per hour. The number of hours, and then that varied, that told me how much money I made. So this is an example that you guys have been doing for a long time. Ooh, word problem. Okay, suppose that y varies directly to k. Y is 9. K, I don't know what it is, but this is negative 15. So let's see here. I'm going to divide both sides by negative 15. So k is equal to, let's see here, 3 will go into both those two. So that's negative 3/5. So y is equal to negative 3/5 x. X is 21. So I go through and I multiply this straight across. That's 63/5. Now, some of you are probably wondering, well, couldn't I just do this as a proportion? Negative 15 over 9 is equal to 21 over, and I'm going to call this y. Well, does this work? So this ends up to be negative 15y is equal to 189. Divide both sides by negative 15. Y is equal to, well, gotta get that calculator again because that's not one of those things I keep in my mind. That's 12.6. Well, but that's not 63 over 5, but this is negative 12.6. And I forgot the negative sign. So yeah, can I do this as a proportion? Sure you can. I really like to do it the way that I've shown because any variation problem that I do, I can set up and do this way. I don't have to remember, hey, if this is inverse variation, I got to set up it differently. I just do the problems a little bit different, but that's how I do those. So I do them all the same. How you choose is how you choose. That's fine with me. So I have some more. So real life example. How about paycheck? That's one. What about distance equals rate times time? That's another one that you can do. How about gas? Miles per gallon. Same thing. So there's all kinds of different ones that I can think of. Graphing direct variation. Well, this is graphing an equation of a line. Notice that the slope is 0. The y-intercept is 0. So go up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Okay. Hey, that's not my cup of tea. Then make a table. I would tell you, keep it small. This is an even number. I would have my x values be even, so it's easy math. I always start with 0. 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times negative 2 is negative 1. So go over 0, up 0. Over 2, up 1. Oh my gosh. Over 2, oh, they're the same ones. And that works out just fine. Okay. Here's your assignment for today. We have a worksheet that's due. The other one, yesterday's homework, we're going to end up, hopefully have that done and able to be collected.